Good day and welcome to this episode where we shall be talking about the grade 11 prediction of mathematics paper 1. Okay, so mathematics paper 1. Okay, so one thing we know that before COVID, the papers were having cool topics for both paper 1 and paper 2. Whereby the assigned topics of paper 1 were fully tested. And the same applied to paper 2. But during the COVID years, it was some content was trimmed off. And that led to papers that did not really have much. Unlike 2023, where things are going to go back to the normal pre-COVID. Okay. So in mathematics paper 1, in grade 11, we have round about 4 topics. Normal, okay. First topic of interest is algebra. And this topic carries quite a lot of marks. We can say plus minus, maybe 45. Usually it's 2 or 3 questions under this topic, algebra. So what one needs to know is how do we work with, let's say, quadratic expressions. Okay, quadratic expressions, and in most cases in grade 11, our focus is going to be equations because we shall be applying the factorization and things like that. Okay. It's going to be rare for someone to ask you to factorize in grade 11. Rather, we want you to do the application. So under these equations, just know how to probably use the quadratic formula, which is the negative b plus minus square root of b squared minus 4ac over 2a. Okay. And we know that this can be obtained if we have the general term of a quadratic expression, which is ax squared plus bx plus c. So the coefficient of x squared will be our a. The coefficient of x is the b, and then c will be the constant. So just substitute it there and then get those answers. In most cases, to be solved for x, okay? And where they ask you to solve and give your answer to decimals, it's automatically requesting you to use the quadratic formula. And then from there, one other thing we can also expect under algebra will be, we can say, still equations that have, no, let me just say inequalities first. Okay, inequalities. So with these inequalities, they will be still in form of the quadratic format. Let's say x squared plus a 2x. Then I'll say minus 3. It can be greater than 0. Okay. So in this case, you still follow the same criteria procedure as though you were solving a quadratic expression. Then get your answers, which answers are now going to be called the critical values. Okay, and now these critical values need to be represented using the inequality format. Now we need to pay attention to the value of a, or the sign of a, and as well as the inequality symbol. So for as long as our a is positive, okay, which should be our emphasis to make sure that the a is positive. And then we look at the sign. For as long as the sign is greater, we have 2 options. Either saying x should be less than the smaller value, and then x must be greater than the bigger value. Okay. This is just one way of representing the solutions. If someone wants to draw, let's say, a parabola in this case, you'll have to look at the format. Okay, so this is going to be like a smiling parabola. And the point of interest, since it is greater, will be to the right, and then will be to the left. So you can shade this area. That's the point of interest. Okay, now that is if we are representing it in that way. Now, if it so happens that the inequality symbol is less than, I'll say x squared still, plus a 2x minus 3 is less than 0. For as long as the a is positive and the inequality symbol is less than, which means our critical values, the smaller value is less x and less the big value. Okay, so how do we get the smaller value and the big value? Just solve that using the quadratic formula or using your vectors. Okay, so that is to do with the inequalities. Now, scenarios under which probably you're given a negative sign as the a, let's say negative x squared, I'll say plus 2x, I'll say minus 3 is greater than 0. Someone can start by dividing through using the negative sign. So that would be x squared minus 2x plus a 3. This is going to be, this is going to make sense. I think my signs are going to give me an issue. Let me just maintain the signs as the first one. So let me just switch the sign here to a minus. And let me keep this as a plus. Okay, so I can divide through by negative, so I have x squared plus 2x minus 3. Now this symbol will change to a less than. And then you represent your expression in the formats that we've seen above, given the conditions. Okay, now that is to do with the inequalities. And then the other type of equations that we love is where we have the root sign. An example, if you have x plus a 2, and then they tell you plus x is equal to 7, and they ask you to solve for this. So in such a scenario, start by eliminating or getting rid of whatever is around the root sign. In other words, we need to isolate the root sign using algebra. Okay, so this x goes that side, then it's going to be a minus x that side. And then we'll be left with something like x plus 2 is equal to 7 minus x. And then it is at this step that we shall have to square both sides. Okay, when you square both sides, one common mistake that grade 11s are making is, yes, they know that this 2 cancels the root sign, and then that is x plus 2. Now, opening this, remember this is a square bracket, which is the same as 7 minus x times 7 minus x. Apply the FOIL, you'll get back to a quadratic. Okay. Now, with that quadratic that you end up with, use the quadratic formula or basically the vectors. Get your 2 values of x. Okay. And then after getting the 2 values of x, we need to test the answers. Okay. So we need to test our values within the original expression. Okay. So what we do, let's say in this case, if x was a 2 or x was a 1, just giving an example, we need to replace this 2 with x. So like 2 plus 2, and then square root of that, and then plus 2, and see whether we're going to get the same answer or the same result as what is on our right-hand side. So the answer or the solution that satisfies the equation is what we go with. And then that doesn't, we just say no solution or not applicable, something like that. Or you just simply cross it out with the equal signs. So x cannot be equal to that. Let's say if it does not satisfy the equation above. Okay. Then besides that, we have this thing that is called nature of roots. Okay, so nature of roots is still under algebra. So under nature of roots, we normally have interest in the quadratic formula, but our main interest is just what is under the square root, what we call the discriminant. So in this case, the value of this discriminant plays a big role in determining the nature of roots. So this discriminant is sometimes called a delta or just a triangle. So I'm going to say if that triangle is less than 0, Okay, then we know that the roots are non-real. Just say non-real, or another word that we normally use is imaginary. Okay, so the roots are just imaginary, they do not exist in real sense. And then if the discriminant is greater than 0, then the roots are real. Then if this discriminant is equal to 0, then we know that the roots are equal. If the discriminant is equal to a perfect square, then we know that the roots are rational. Okay, so roots can be real, they can be equal, and they can be rational. So in most cases, it could be 2 or 3 characteristics in that case. Okay, so that is to do with the nature of roots. Then, besides the nature of roots, we have the surds. Okay, we have the surds still under algebra. All we need to know is how the surds work. Let's say you're given the root of 8. How do we break this down? Okay, that's the same as 2, the root of 2. How did we get that? Look for a number that you multiply, or look for 2 numbers you multiply, but one of them has to be a perfect square. So that is 4 times 2. When I split this up, I'll have the square root of 4 times the square root of 2. So we can find the square root of 4, which is 2, and then the root of 2. So we just need to know how to expand or simplify the surds in that format. Then still under this, we need to know about the rationalization. Okay, rationalization is more like eliminating the root sign from the denominator. And we have a number of ways of doing that. I'll give the first case scenario. Let's say if we just have one term within the denominator, just square root of b. So what we do in this case, just multiply the numerator by the same denominator, times root b times root b. So the top part is just going to give you square root of ab, and then the bottom part, we shall just get a b. Because root b times root b, we shall get root b squared. And then the 2 is killed with the root sign. Okay, so that is if we just have one term. Then what happens if we have more than one? Let's say you have root a minus, I'll say root c. You just multiply by this bottom part, but you have to switch the sign. So it can be root a plus root of c over root a plus root of c. The reason as to why we multiply the top and the bottom is because we're just introducing something extra that was not part of the question. And then do the opening up. Bottom part is just the difference of 2 squares. So when you open that up, you'll have a plus root ac over a minus c. So something like that. Okay, so that is to do with the sides. Then the other last part is the exponents. We expect exponents to be under the first 2 questions, or the first 3 under algebra. So under this, just know the laws of exponents. Okay, we have quite a number. So the laws as well as the rules of exponents, the definitions and all of those things. When you're multiplying numbers with the same basis, what we do to exponents? When you're subtracting and dividing, all of those things. And what we like in most cases is if you're given, let's say 4, maybe the 4th root of a. What does this mean? We know that this will be the same as a to the exponent of a quarter. Let's see the 5th root of maybe a cubed. This would be the same as a cubed to the exponent of 1 over 5, which is a 3 over 5. Okay, just need to know how to play around with those powers or those exponents. Then the last part will be simultaneous equations. So this is an everyday scenario, especially for as long as this mathematics paper. Most papers have these questions of simultaneous. And in this case, we shall have what we call a linear equation, and then we also have what we call a quadratic one. So the advice is start with the linear. make something the subject, either make X the subject or make Y the subject, depending on which one is easier to deal with. Then whatever you made the subject, just substitute it into the second quadratic equation and then solve. In grade 11, we expect people to have at least 2 values or 2 answers for X and 2 values for Y. Okay. At worst, you can get 4 values and 4 values, depending on the scenario. Okay. But minimum should be 2 values. So that is under question number 1. You just need to remember all of that. Then the second topic that I'll just look at is the number patterns. Okay, number patterns. Some people call them sequences and series, but that's a grade 12 language. In grade 11, we just call them number patterns. So this is gonna carry not that much. I'll say maximum of 25, but plus minus. Okay, it can be less than 25 or even more than 25. So under this, we only have 2 patterns that we learned about in grade 11. Okay, so that is the arithmetic. Okay, so this arithmetic is also known as the linear patterns. So what we know about this is that there is always a constant difference. This is the key distinction between these patterns, constant difference between the terms. How do we get the difference? Let's say we get T2 minus T1. Or we can get T3 minus T2. In other words, we are subtracting consecutive terms for us to end up with the differences. So we need to know how to work with a common difference, how to determine the general term or the general rule. Then I know some grade 11s are using grade 12 concepts or approaches of getting that. You're still allowed for as long as it is mathematically correct. And then the other one that we do in grade 11 is what we call the quadratic pattern. Okay. So the general term, let's say the general term of the linear or the arithmetic, we know the Tn is always going to be An plus C or An plus D. It doesn't matter. But I don't want to use the D part because it will mean something else. It will mean something else. Let me use maybe F, doesn't matter, any letters, or Bn plus P or whatever. But that is the format. Then with the quadratic, more like a parabola, the ax squared, the bx plus the c. What we know about the quadratic is that we have 2 differences. Okay, so 2 differences. So we have the first difference and then the second difference. So we know that the second difference will always be equivalent to A, and the second difference is always constant. The first difference forms what we call an arithmetic. And then the first term of the first difference gives us the 3A plus B. And then the first term of the quadratic will give us the A plus B plus C. We shall see that when we are determining or when you're going through some papers and how we work around this. So just know how to work around with, let's say, if you're given the Tn and how do you solve for the n quadratic formula or factorization. Okay, in cases where they're asking for, let's say, T20, your n is a 20. Because remember, this is the Tn. N will be a 20. So if it's Tn, it's going to be An squared plus a Bn plus a C. We're no longer going to use the X and stuff like that, but we still use a quadratic formula. Now, in most cases, let's say when they ask you which term, or if they ask you is a particular number a term in the sequence, yes, you may do your calculations and try to solve for n. One thing we need to know, n should never be a decimal, okay? And n should never be negative. So this we don't entertain under number patterns because we cannot have a negative position, or we cannot have a position that is a fraction, okay? So that is to do with the number patterns, 25 plus minus. The next, we have what we call the functions. Functions, this carries quite some chunk of marks. So some people call them graphs. It's fine, functions and graphs. So this, we say 40 plus minus, can even be 45 marks, just functions alone. So under functions, we look at graphs to do with, I will start with the basic one, which is the parabola, which is always a must. Okay, so parabola, we know that it can either be in that format or in that format, depending on the value of A or the sign of A. The general form of a parabola, we have three: ax squared, bx plus c. Now this can be f of x, g of x, h of x, p of x, it doesn't matter. All these ones represent what we call the y. Now we also have what we call the intercept format of a parabola. Okay, I'll say f of x is equal to a into x minus x1, x minus x2. So we know that x1 and x2 represents the intercepts or the x-intercepts, this one and that one. In other words, if a graph is drawn, the points where the graph is cutting the x-axis, these are the points that are representing x1 and x2. For you to get the A, you just need one extra point along that graph. Then lastly, we have what we call the turning point format, which is x plus or minus p, we square that, plus minus q. So this last format is what we call the turning point format. So if we ask you for the turning point, the coordinates will be p and q. So this p represents the x coordinate of the turning point, q represents the y coordinate of the turning point. So those are the formats that we need to know. Then under the parabolas, at least just know how to determine the axis of symmetry, because we love this in most cases if you're asking for the points or if you're asking for the turning point. So we know that x is negative b over 2a. That we need to remember. Then the x value we get, just have to substitute it into the original equation for you to end up with the y value, which will be the turning point. Now, if we have, let's say, the x-intercept format, you can just get the midpoint. Okay, remember we have this and that. Get the midpoint of these points. And then whatever you get will be the axis of symmetry. If you have the the turning point format, you don't need to calculate. In most cases, we ask for such a question, or if they ask you such a question, they'll give you 1 mark because the answers are just there. All we need to do is just switch the sign. If there's a plus in the brackets, then you have a minus there. If there's a minus in the bracket, then you shall have a plus. The sign of the Q will always be the same. If there's a plus Q, then that's a plus Q. If it's a minus Q, then we end up with a minus Q. Then the other thing is the intercepts. How do we determine the intercepts? So we know that for x-intercept, okay, our y is always going to be a 0. And then for y-intercept, for us to determine the coordinates of the y-intercept, we substitute x with a 0. So this, we just need to remember. Then the next question could be maybe sketch. That's it, if they want you to draw the parabola. But in most cases, it's drawn for you. Then things to do with domain and range. So domain, these are x values. So the domain of a parabola is the same. X is always an element of real numbers. What this means is that this parabola can extend to the negatives. It can also extend to the positives. It's not restricted. It's only in grade 12 that we shall talk about restricted graphs. Then the range, when you talk about range, we shall be focusing on the y values. So we're going to say that with the range, either y is less than the turning point value. I'll say TP of y, or y will be greater than the turning point of y, or the y coordinate of the turning point. What does the less than mean? So if your A is a negative, In other words, it's a frown face, then the range must be less. So in other words, you're looking at the Y value there and below. Then if your graph is a smiley face, okay, so you're looking at Y values that are above. So if this is a minimum, that is a maximum. So if you have a maximum, use less than. If you have a minimum, it has to be greater than. Okay, so that is to do with the parabola, basic. Then next you have the straight line. Straight line, we know that y is equal to mx plus c. M is the gradient. This is the y-intercept. How do you get the gradient? From your paper 2, you say y2 minus y1 over x2 minus x1. That is the y-intercept. So just get any 2 points and then do the magic. Then the other graph that we always love is the exponential. Exponential. So in most cases, we give you b to the x probably plus a q. Now we know, oh, okay, someone said the straight line could be that way, or it could be in that form. Okay, so we know that if it's in this format, the gradient is negative. If it's in this direction, the gradient is positive. We know that parallel lines have the same gradient. And then perpendicular lines, the product of the gradients must give us -1. Then with exponential, one thing we need to know is that if b is greater than 1, okay, then that's going to be an increasing exponential. Something like that. If our b is between 0 and 1, in other words, it's a fraction, then that's going to be a decreasing exponential. This q here represents what we call an asymptote. So if the question asks you for the equation of the asymptote, just tell us y is equal to the q. If this is a 2, then y is equal to a 2. That would be the equation. If this is a -2, then y is equal to -2 will be the equation of that asymptote. Remember, an asymptote is a point that the graph should never cut. Okay? That is to do with exponential. When you talk about domain, x is an element of real numbers, range must be greater than the asymptote always. Intercepts follow the same format we said. X-intercept, y is a 0, y-intercept, x must be a 0. So that is an exponential. Then lastly, we have what we call the hyperbola. This has been coming over and again. So we have 2 scenarios. If our a is greater than 0, then we expect the hyperbola to be in 2 quadrants, quadrant 1 and quadrant 3. Then if our a is less than 0, in other words, it's a negative, we expect the hyperbola to be in quadrant 2 and then quadrant 4. But these quadrants will be based on what we call the asymptotes. So the general equation of a hyperbola is a over x plus minus p plus minus q. That's mine. This p represents what we call the vertical asymptote. Then q represents what we call the horizontal asymptote. So if they ask, because it's usually the first question, let's say if you have a hyperbola, they'll ask for the equations of the asymptotes. Okay, get the x, switch the sign. So in other words, like x plus p equated to 0, and then solve for this. So x in this case will be minus p. Then y is going to be just equal to q. So these will be the equations of the asymptotes. Ask you for x-intercept, y-intercept, follow the same scenario. X is a 0, y is a 0, solve whatever you need to get. Then when it comes to the domain and range, something interesting. So domain, x will be an element of real numbers, but x should never be equal to the asymptote. Same story with the range. Y will be an element of real numbers, y should never be equal to the asymptote. So that's all we need to know with these functions. I know they could be giving you 2 graphs, or let's say you're given 2 graphs and those 2 graphs are meeting up somewhere. At the point where the 2 graphs meet or intersect, the 2 graphs will be equal to each other. So let's say if you're given f of x and then g of x, you just have to solve for them in that form. You get the 2 functions or the two formulas or equations and then solve for the x. Okay. For scenarios where they ask you for x is greater than g of x, okay, look at where the graph of f is above. Let's say this is our f and then probably this is our g. Okay, we can see that f is above g between these points. So you read off your x value there and then the x value there. So it's between these values that the graph of f is going to be above. For cases where they talk of f of x times g of x is greater than 0, we shall be focusing on the x axis. And then we look at which graph is above, which graph is below, and all of that. We shall look at that under our given examples. And then I think I can just wind up that with the functions, just to remember that. Then next, we have finance. Finance, not quite a lot, plus minus 15 marks. Okay, so under this, we just need to know our formulas. I'll start with the effective. Okay, effective and the nominal rates, just know how to do the conversion. Okay, sometimes learners will be given the formulas for grade 11, just for the final year exam alone, sometimes. And at other times, they don't give them. So just know your formulas well and good. Then we need to know the compound interest, that is 1 plus I to the exponent of n. So this is also known as the growth. Okay. Then we also have what we call reducing balance. Reducing balance, that is to do with the depreciation. Now the compound decay. And then we also have what we call the straight line depreciation. Straight line depreciation. That is 1 minus IN. At least in grade 11, we should know what the A represents, the P represents, and what the N represents. Okay. Then from there, the other thing that we need to also work with is the timelines. Okay. Timelines come into play if, one, we have changing interest rates, or there is some bit of change within the investment or within the loan that was given in terms of withdrawal and probably more deposits taking place. Then we can apply our timelines. Okay. What else do we need to know about finance? Probably the compounding periods. Yeah. Because in most cases, it's in grade 11 that now we are introducing the compounding periods. Let's say if the interest rate is compounded monthly, what happens? So you divide the I by 12 and then the N, which is the number of years, you multiply it by 12 to get how many months are we going to be compounding. Then if it's quarterly, we know that we're going to divide the I by 4, multiply the N by 4. We only multiply N by 4 if N is in years. If N is in years. But if it's already in months, then we don't need to multiply. Okay. Then if it's, which other one do they normally use? Semi-annually. Okay, so semi-annually, or sometimes we call it half-yearly. Divide the I by 2, multiply the N by 2. Weekly, we're dealing with 52 weeks in a year. And then daily, 365 days in a year, and so on and so forth. So that is to do with the finance. We at least need to know this before going for the paper. Then lastly, measurements, not really. I'll just talk about probability. Okay, probability, not quite a lot, but plus minus 25. It can be less than 25 or slightly close to 25. So what we need to know about probabilities, and in grade 11, it's quite a lot. Okay. One, we need to know what mutual exclusive means. Okay. We need to know that probability rule or the addition rule, probability of A plus probability of B minus the probability of A and B. Okay, so if events are mutually exclusive, what happens? If events are independent, okay, then what happens? We need to remember that if events are mutually exclusive, the A and B will be 0. If events are independent, probability of A and B will be the product of A times B. And then we just apply this formula if they are asking for it. Then we also need to know how to draw and work with tree diagrams. Okay, with tree diagrams, if we look at, let's say, with replacement and also no replacement, just know how to get those branches as well as indicate the probabilities as well as the outcomes. Then after that, we also have independence or testing for independence. In other words, you'll be given a two-way table or a contingence table, and then they ask you if some events are independent. Let's say if I'm talking about male and choosing probably cheese, are they independent? So you just get the probability of male times the probability of choosing cheese and see. If you multiply the two, it give you the same probability as the male chose cheese. If the answers are the same, then the events are independent. If they are not the same, then the events are dependent. Now with this, normally I advise people to work with 4 decimals, but then it's your final answer that you should probably approximate to just 2 decimals before we can compare, because in most cases, it's very hard to compare with 4 decimals. But with 2, we can easily get a pretty clear picture of what is happening. And then lastly, we need to look at the Venn diagrams. Okay, Venn diagrams. Most cases, 2 sets, not a big deal. 2 sets can be brought if we're talking about the mutual exclusive and the independent. But in grade 11, we love the 3 sets. 3 sets. The 3 sets. Just know how to work around with them and the terminologies that are used under that. So guys, that is basically what I can say about paper 1. So I just need us to get a paper and work out at least 1 paper. I have quite a lot, but I'll just use just 1 paper. Okay, so that is 2021 or 2018. That's fine. Let me use the 2021 one since it is a bit recent. I'll use the Gauteng province one. So question 1. They're telling us that if you're given P, okay, so question 1 is typically algebra, okay? P is given as this. We have the product of the numerator and the denominator, then determine the value of values of x for which P is equal to 0. So remember, P is that entire thing. So if you get the whole thing to 0, it's like x plus 2 multiplied by 2x minus 1 over 3 minus x is equal to 0. When you try to solve for this, multiply both sides by the denominator, you're going to end up with a 0, and you'll be left with just the 2 sets on top. Okay? In such a scenario, 2 brackets giving you 0, you don't need to open. Just switch the signs and get the x. So in the first case, we can say x is a negative 2. Or if we solve for x using this bracket and equating it to 0, we can say x is going to be a half. What I'm saying, x plus 2 is a 0, get the x. Or 2x minus 1 is a 0, then you solve for x, you get a half and the negative 2. So that would be 1.1.1. Then when they ask for something that is undefined, something can only be undefined if the denominator is equal to 0. So in this scenario, our denominator is the 3 minus x. So if I get 3 minus x and equate it to 0, and then I solve for x, which means my x is going to be 3. Okay, so that is it. Then 1.2.1, 2x squared minus 3x minus 4. So this kind of scenario, just forces us to use the quadratic formula because they are telling you correct two decimals. They already know we cannot get it using just the normal factorization. Okay, but if you can still do or use your magic and get it, well and good, but I'll go for the quadratic formula. So 2x squared, okay, we're saying 2x squared minus 3x minus 4 is equal to 0. Let's just confirm. 2x squared minus 3x minus 4 is equal to 0. So our A is a 2. Our B is a negative 3. Our C is a negative 4. So the number together with the side, okay? Then from the quadratic formula, negative B plus minus square root of B squared minus 4AC over 2A. Do the substitution. So negative and negative 3 plus minus square root of negative 3 squared minus 4 times 2 times negative 4 over 2 multiplied by 2. Please and please, many times I've seen learners that just go straight away. They just write the quadratic formula and then they write the answers. That is wrong, because you're going to lose the marks for the substitution into the quadratic formula. You'd rather show us the substitution in the quadratic formula than giving us the formula and then give us the answer. It makes no sense. Okay, so if that is the case, I'll just punch that into the calculator. Remember, you'll have to use one sign at a time. Okay, so either you start with a plus or a minus and then get your solutions. So what I'm getting, depending, since they say two decimals, don't give us answers that are in sad form. So I'm getting negative 0.85, and I'm also getting 2.35. So those will be our answers, and then you'll get all your 3 marks. Okay. Then for this case, remember we said inequalities. But as long as this is not a 0, you'll have to open the brackets. As long as your right-hand side is not a 0, is a number, open the brackets. So how do we open? The following. So it's saying 2x plus 3. Okay, 2x plus 3. And then we multiply by 3 minus x. 3 minus x is greater than 4. Open this up. So 2x and 3, that is going to be 6x. 2x and that's going to be minus 2x squared. 3 and 3 is a plus 9. That's a minus 3x is greater than 4. Collect the like terms. So negative 2x squared. This and this is a plus 3x. When I move this for that side, transpose it, I'll get a 5 is greater than 0. Then I'll divide through by negative since I want my A to be positive. So this is going to be 2x squared minus 3x minus 5 is less than 0. Since I divide with the negative, the inequality symbol must change. And then I'm going to use my factors, or you can use the quadratic formula, no problem. So this is going to be 2x, that's going to be x. Numbers that I multiply to give me 5. I only have 5 and 1. I can put here minus, I put here plus. Let's see. It's a plus 2 minus 5. Perfect. So which means x is going to be a 5 over 2, or x is going to be a negative 1. Remember, these are just my critical values. They are not my solutions. So I need to represent these solutions. Okay. So now, since I divided through and I got my sign as less than, then I'm just going to say that negative 1 is less x is less 5 over 2. And then that would be my solution. Then the square root part, remember I said, isolate the root side. So leave the root x plus 2 on one side, move the x to that side. So if I do that, I'll end up with square root of x plus 2 is equal to 4 minus x. That's going to be our first step. Because this x is positive, when it crosses the equal signs, it becomes negative. Then the second step is for me to square both sides. Okay, square that side, square this side. So the 2 kills the root sign. I'm only left with x plus 2. Remember, you open this up using the FOIL. It's 4 minus x times 4 minus x. Don't say 16 minus x squared. That will be wrong. So that's going to be 16 minus 8x plus x squared. Move everything to one side. I'll have x squared minus 9x plus 14 is equal to 0. Okay. I can use my quadratic or the factors. I have x and x. I'll have 7 and a 2. Okay, when I simplify this, x is either 7 or x is basically a positive 2. Now, remember we said, for as long as it's this kind of question, we do not stop at that. Okay, we need to go back and test. So how do I test? I get the 7 and punch it in. Okay, 7 plus 2 is 9. Square root of 9 is going to be a 3. Okay, and then 3 plus the 7, I get a 10. On my right-hand side, I have a 4. So this is not part of the solutions. What if I try with the 2? 2 plus 2 is a 4. Square root of 4 is 2. And then I plus the x, which is a 2. I end up with a 4, which is my answer on the right-hand side. So this is our solution. So we can say no solution or not a solution. So that's how that question could be answered. Then 1.2.4, if I can squeeze it in. So with this, it's an exponential equation, which will require me to do some bit of splitting up. So what I'll start by doing, I'll say 2 to the 2x plus 1 can be written as 2 to the 2x times just the 2 to the 1 is fine. Minus, when I split up that, I have 3 times 2 to the 2x multiplied by 2 to the negative 1. And then break down the 4 to a base of 2. That's going to be 2 to the 2x is equal to 12. So what I'm seeing is that there is a 2 to the x across. Now, when I have plus minus signs involved, I'll apply my factorization. Take the 2 to the x out. I'll be left with this 2. Minus, remember this is out. If there's a number with a negative exponent, that number can become a denominator if it's initially a numerator. So I'm going to be left with 3. To say 2 can go down, comes a denominator. Okay. Then from there, why am I still losing the bracket? There's still something extra. Something extra. And I remove the 2 to the x from there. I'll be left with a plus 1. This is equal to 12. Then I'll simplify what is in the brackets. 2 minus 3 over 2 plus 1. That gives me 3 over 2. So 2 to the 2x multiplied by 3 over 2 is equal to 12. Divide both sides by 3 over 2. Divide by 3 over 2. So 12 divided by my answer, I get 8. Okay, so it's like 2 to the 2x is equal to 8. Now I can create the same bases. So 2 to the 2x is equal to 2 to the 3. Okay, is that true? Yes. Then, since the bases are the same, I'll drop them and then solve for x, which means my x has to be 3 over 2. So that's how I would have worked out that question in particular. Then we move on to 1.3. If we're given f of x as this, so function of x is given as that. Can we calculate f of 2? So remember, x is being replaced with a 2. Then let's do the substitution. Now, there's x, we're just going to put a 2. So that's going to be 2 squared plus 8 times 2 plus a 16. What we get? That's a 4, 32, so I'm getting a 36. Done. Then for which values of x, or determine the values of x for which f of x is greater than 0. So get that x squared plus 8x plus 16. Just say it's greater than 0. And then try to solve this quadratic. So you can use the factors, or you can use the formula. This is the square because I'm seeing a 16. So that's like x plus 4 squared is greater than 0. So we just have equal root c. So which means our x is going to be a negative 4. Okay. Now, since we're looking at f being greater and we're looking at just 1 point, what this means is like this parabola would be in this sort of format or scenario where it's cutting 1 point at negative 4. Now they're asking us for which values of x is this graph above. So you can see that everything on the right and everything on the left for all values of x on the right of negative 4 and on the left of negative 4. So what I'm going to say, I could simply say that x is an element of real numbers, but x should never be negative 4. Just that. Or someone can say x must be greater than negative 4 and x must be less than negative 4. Either way. 1.4. 1.4. So for x and y, 6 marks. So this is simultaneous. So they're telling us that y minus 2x. Okay, y minus 2x plus 1 is a 0. Then the second equation is xy is equal to we have 2y squared. Is it 2y squared? It's just 2y. X squared plus 3x. X squared plus 3x minus a 10. This is just a 2y. Okay, so 2y x squared plus 3x minus 10. Perfect. So step number 1, we said identify which one is the linear and which one is the quadratic. So the linear one is always the one that doesn't have any squares involved. Okay, get one of the letters and make it the subject. So y is the easier one to make the subject since it doesn't have any coefficient. So I'm going to move the 2x and the one that side. So which means y is 2x minus 1. I'll call this my equation star. If this was equation 1, this is equation 2. And then I'll substitute equation star into equation number 2. So where I see y, I'll just replace 2x minus 1. So that is x into 2x minus 1 is equal to 2x minus 1, and then plus the x squared plus the 3x minus the 10. Open up the brackets, create a standard form. Okay, so that is 2x squared minus x is equal to 4x minus 2 plus x squared plus 3x minus 10. Collect the like terms. I don't know. I think I'll move everything to the left. So when this x comes that side, I'll be left with just x squared, because the subtraction. Then I'll have 4x plus 3x, that's a 7. Then 7 minus 3, or this minus 7, I'll have minus 8x. Minus 2 minus that, that's minus 12. When it comes outside, I'll have a plus 12. Is equal to 0. I would prefer using the brackets because it's quicker for me, but you can still use the quadratic. So that's x and x. The two numbers will be 6 and the 2. Both of them should be negative. So either x is a 6 or basically x is a 2. Then I'll get my values of x and substitute them into equation star. Get here. So which means my y, if x is a 6, will be 2 times 6, that's 12 minus 1, that's 11. If x is a 2, 2 by 2 is a 4, minus 1, y is a 3. So it's either 6 and 11, or basically 2 and 3. That's what I'm ending up with. Then 1.5, for any real value of p, can we prove that the roots are non-real? Remember, we said for roots to be non-real, the discriminant must be less than 0. In other words, should be a negative throughout. So let's open up this entire thing and create a quadratic format of x squared, bx, and c, and then get those values and try to get the discriminant. So when I open my left-hand side, I'll be left with x squared, p squared, plus a 3 is equal to 2xp minus 2x squared. I'll move everything to one side, which is the left-hand side. X squared, p squared, plus 2x squared. Okay, I'll say minus 2xp plus a 3 is equal to 0. Now let me reorganize this into the a, the b, and the c. So what I'm seeing I have x squared and x squared there. I'll take that out. I'll be left with just 2 plus a p squared. In this case, it's just a minus 2p with x, and then a plus 3 is equal to 0. So I can see that my a is the whole of this, since it's the coefficient of x squared. This is going to be my b, that's going to be my c. So let me try to substitute into the b squared minus 4ac format. Okay, so what's my b? It's minus 2p. I'll square that. Minus 4, our a is 2 plus p squared. Our c is a 3. So I can combine this 4 and a 3 to give me a 12 and then open up that. So when I simplify that, I have 4p squared. 4 and 3 gives me a 12. We said minus 12 times that, that's a minus 24. And then minus 12 and that, I'm getting a minus 12p squared. 4p squared and 12p squared, those are like terms. Let's simplify them. So I have minus 24 minus 8p squared. Now we can see that everything is a negative. Okay, so whichever number of p that you replace here, for as long as you multiply it with a negative 8, it's going to be a negative. And then you subtract a 24, it's still going to be a bigger negative number. So which means we can never have numbers that are greater than 0. So from that, we can just draw the conclusion and say, therefore, what did they say? Can you prove that for any real value of p, the roots will always be non-real? That's all you have to say. Number two, these are exponents. What we see in the brackets, x squared, x negative 2, and then we have negative a half. So let's start by simplifying what is inside the brackets. 16 and 81, nothing can divide them, so I'm going to keep them the way they are. Okay, and then when I try to simplify the bases of x, I can move this to that side, so that becomes a positive 2. Or it can be basically a 2 minus minus 2, which is going to end up as x to the 4. Everything is the negative I have. So I can switch them around so that I end up with a positive exponent. So it's going to be like 81 over 16x to the 4 to the exponent of positive a half. Remember, negative exponents do switch around the numerator and denominators. Now, what I can sense is that exponent a half is the same as square root. Okay, so what is the square root of 81? It's 9. What is the square root of 16? It's a 4. Square root of x to the 4 becomes x squared. So that becomes our answer. Okay, then 2.1.2. Okay, it's also an exponential kind of expression. I'll say 9 to the x. I'll just jot it aside. We have 9 to the x plus. We have 3 to the 2x plus 1. 3 to the 2x plus 1. I'm dividing everything by 18 to the x. 18 to the x and then 2 to the negative x. So what we see, we're seeing different bases. We have some bases of 2, and then we have bases of 3. So first things first, create the simpler bases, okay? Break down the 9 to a base of 3. We know that 9 is the same as 3 squared. So 9 is going to reduce to 3 to the 2x. And then when I split this up, I'll have 3 to the 2x times just the 3. 18 can be written as 3 squared times 2. You can just press 18 in your calculator, press the equal sign, and then you press that button of the FACT, the factorization button. You'll get this. So if I have an exponent of x, this x will be distributed so that I have 3 to the 2x multiplied by 2 to the x, now multiplying by 2 to the negative x. Okay, whenever we have plus minus signs, factorization has to take place under exponents. What is common? 3 to the 2x. So I have 3 to the 2x. I'll be left with 1 plus a 3. Over, I have 3 to the 2x. This is times a 2x. We said for as long as you have a negative exponent, pushes it to a denominator, something like that. Now what I can see is that it's game over for this question. So this cancels out with that. This cancels with that, give us a 1. Then 1 plus 3 is a 4. So that's what we need to do. Okay. Then 2.1.3. Question says without a calculator. Wow. I'll write to this side. Square root of 10 minus, say 3 to the 2x is equal to 3 to the x minus 2 is equal to 3 to the x minus 2. Okay, so what we do here, okay, remember for the previous questions that were involving exponents, we just had just the same exponent. 2 to the x is x and is x, and they will cancel it out automatically. In this scenario, it's a bit different because now we see this is a 2 to the x. This is just a plain x. We use what we call the K method. Okay, so we can say it's not necessarily K, but any T method or Y method or whatever method. We can select 3 to the x because it is the smallest exponent, just a plain x, be equal to, I'll say t. Then I'll go back and say 10 minus, this is going to be now t squared, is equal to t minus 2. How many marks is this question? 5 marks. It's worth it. It's worth the struggle. So what I'm going to do, I need to square both sides so that I get rid of the root sign. Okay, so that's going to be this squared and then that squared. So the 2 kills the root sign. I'll be left with 10 minus t squared. When I open this, the FOIL is t squared minus 40 plus a 2. Okay, so what we do, we can move everything to the right. So that's going to be 2t squared minus 40. When I move the 10 that side, I'm going to be having a negative 8 is equal to 0. Divide through by 2. I'm having this. Does that make sense? Kind of makes sense. Okay, so if I am to, let me just go back to say t minus 2. T squared minus 40 plus, no, there's a lie here. This is meant to be a 4. This is a 4. If that's a 4, then this is going to be negative 6. And that's going to be negative 3. Okay, 6 and a 3. Okay, open that up. That's a t and a t. It's a 3 and a 1, or say minus and plus. So either t is a 3 or t is negative 1. Remember, the question wants you to solve for x, not for t. Since we said t was a 3 to the x, then replace it back. And say 3 to the x is a 3. In this case, the bases are the same, which means even the exponents have to be the same. X is a 1. Now, when you look at this, it's a negative. We have no scenario where we get a negative answer if we're dealing with exponents. So we shall say no solution, or you can just cross it out in that sort of format. So the only answer we have would be a positive 1. All right, then 2.2. Verify without a calculator that this whole thing is equal to this. They're not asking you to solve, they just want you to verify. So under verification, it's like a proof question. You're moving from one side and you must end up on the other side. So what I'm going to do, okay. I'm gonna start by the left. I'm gonna start from the left-hand side, whereby I will try to square the left-hand side. Remember, it's not squared, but let me square it. And then afterwards, I'll get rid of the square by finding the square root. Okay, so 3 root 2a minus 2 root 3a. I'm squaring it. So when I square that, it's going to be like 3 root 2a minus 2 root 3a. Then I open this up. Remember I said I'm squaring. If not, I can square and then also find the square root at the same time, no problem. So when I open this 3 and that, I give me 9 times the 2a. And I multiply this and that, I'm going to get negative 6 root 6a. Then this and that, I'm going to get a 6 root 3a. Is it? No, 6a. And then this and that, getting a positive 4 times that times 3a. Then I simplify, that's going to be 18a minus this and this is 12 square root of 6a. This and this, I'm getting a 12a. So 12 plus 18, I get a 30 minus 12 square root of 6a. So since we squared initially, we must get rid of that square using the square root. So we must find the square root. And then we have our left-hand side. So we verify that. Okay, question number 3. Table below indicates the minimum number of matches required to construct a triangle. So 1, 3, no, it's 3, 5, 7, A and B. So they want us to get the numerical number of values of A and B. So when we look at this pattern, it's like it's a +2 everywhere. So for as long as the difference is constant, this is a linear or arithmetic. So for us to get A, we plus a 2, which is a 9. And then B, it's going to be 11. Perfect. Determine the general term. So with the general term, use your tricks, use your magic on how to get this. So since we are adding 2 everywhere, I don't need to go through formulas. And what I'll just say 2, and I attach the n. Then I'll get 3 minus 2. I'm getting the first term minus the difference. So 3 minus 2, I get 1. So which one is positive? So +1. Then how many matches will be required to create 100 triangles? In other words, they want us to look at T100. So where there is n, put 100. So 2 times 100 plus 1, we get in 201. Then how many triangles can be made with 3 or 5? So our Tn is 3 or 5. They want us to get n. So we shall say 3 of 5 is equal to 2n plus 1. Move the one that side. 3 of 4 is equal to 2n. Then divide both sides by 2. Say 3 of 4. Yes. Divide by 2. I'm ending up with 152. Okay, triangle number 152 is going to have 305 matches. Then we have 3.2. 3.2. The first three terms of a linear, they love this, because people hate algebra. Determine the possible values of x. So one thing we know about a linear, it has a common difference that is the same. So we're going to get the difference here, which we're going to call D1. Okay. And then the difference here, which we're going to name D2. But we know that D1 and D2 must be the same. So how do we get D1? You subtract the second term and the first term. So 2x minus 2x is a 0, 5x minus 5x is a 0, 2 minus 5 is a negative 3. So my D1 is a negative 3. This has to be equal to, what is 3x squared minus 2x? I'm getting just x squared. And then a 4x minus a 5x, that's a negative x. And then minus 3 minus 2, that's a minus 5. And then I solve this. So it's going to be x squared minus x. When I move this that side, I'll have a minus 2 is equal to 0. Open your two brackets. So apply the quadratic formula. I'll have a 2, I'll have a 1. I'll say minus and plus. I open this up here. So either x is going to be a 2 or x must be a negative 1. So those are the values of x for this to be a linear pattern. That's how you do that. Then question number 4, which is the quadratic. They're telling us the first 4 terms of the quadratic are this. Can we calculate the value of values of x? So what we do, one thing we know about a quadratic is that the second difference has to be the same. So we apply that principle in this case. So let's get the first difference. So it's going to be x minus 1, which is x plus 1. When we get this difference, it's 3 minus x. Get that difference, it's going to be x plus 5. Then when I subtract this, so it's like 3 minus x, I'm subtracting x plus a 1. So that's 3 minus x minus 1, which is minus 2x plus a 2. When I get the difference there, it's like x minus x, that is a 2x. 5 minus 3 is a plus 2. So everything is in terms of x. But one thing we know about the second difference or second differences is that they have to be the same. So I'll equate this together. Okay. So when I move the 2x that side, I'll end up with a negative 4x. When I move this that side, I'll end up with a 0. Divide both sides by negative 4. So x becomes a 0. X becomes a 0. Then they want us to show that the nth term can be written as this. Remember, quadratic is more like a parabola. And this formula that I see involves completing squares. Just that knowledge. So I'm going to replace my x with a 0 and try to find the Tn. So we have negative 1 as our first term. We have 0. And then we have 3. And then we're going to have 8 since x is a 0. So our difference here, 0 minus 1, that's a 1. 3 minus that is a 3. 8 minus 5, sorry, 8 minus 3 is a 5. So I'm having a 2, I'm having a 2. So we say that this second difference represents our 2a. So I'll say 2a is the same as 2, a is a 1. Then this first term here represents the 3a plus b. So I'll say 3a plus b should be equivalent to 1. But our a is a 1. Substitute a with a 1 and transpose it aside, which means b is a negative 2. Then a plus b plus c should be equal to the first term of the quadratic. So a plus b plus c is the first term, which is a negative 1. Do the substitution, 1 plus a negative 2 plus a c is equal to negative 1. And this is going to give us negative 1, move it that side, which means c is a 0. C is a 0. So which means our Tn is going to be n squared minus 2n plus a 0. Does that make sense? It does. And then how do I complete squares? Remember, with squares, I will just need to get the n and get a half of this b. A half of b or a half of negative 2 is going to be negative 1. And then I'll square that. Then that a half, I'll have to add it. Remember, initially, let's see, it's addition and subtraction. So it's like n squared minus 2n. I'll say plus a half of this, which is negative 1 squared. And then I subtract the negative 1 squared also. Then what happens next? Okay, what happens next is that these 3 terms, the first 3, will give us this bracket here when we try to group it back into the factorization format. And then we're going to be left with just the minus 1 because negative 1 squared is just the 1. So this is what they wanted us to give. Okay, then we shall move on and say, calculate the 65th term, T65. Okay, just substitute either here or wherever. So that's a 65 minus 1 squared, and then minus 1. So when I punch this into my calculator, minus 1, I go minus 1 squared, then minus 1, I'm getting 4095. Or you can use the general term that is not in this format and get the answer. Then what is the first value? Or what is the value of the first term of the pattern that is greater than this? So if I have my Tn as this, where there is Tn, I'll use the inequality. So I have n minus 1 squared minus 1 is greater than 9,800. I can move it that side and then find square roots everywhere. Let me just use that other format. The n squared minus 2m is greater than 9,800. Is that true? Yes. Then I can create a quadratic. N squared minus 2n minus 9,800 is greater than 0. Substitute that into your quadratic formula. Okay. If I punch that into my quadratic formula, I'm getting 2 answers. It's either, I'll say my critical values. No, it's fine. N is a negative 98 and then N is 100. One thing we said under the starting phase was that we can never have n as a negative. So automatically this is out. Okay. But then this 100 is going to give us the 9.8 straight away. The question is asking for where the value is greater, the first term that is greater. So the closest of the positions, when I say n is 101. So that's how that could be answered. Then 5.1, it's about finance. I don't know, we can do just bits of it so that we rush through it. Okay, just touch here and there. So a school purchased the printer for 250,000. The printer depreciates. Depreciation is like losing value on this method, reducing balance. The printer will be replaced after 5 years, and then the inflation rate is this much. Calculate the book value. So book value is more like the current value of the printer. I'll not say current value, but the price that the printer will be in 5 years' time if depreciation took place. So since it's reducing balance, it's 1 minus I to the exponent of n. So it's going to be 250,000 into 1 minus, we say 10%, or you can say 10 over 100 to the exponent of 5. Let me just substitute this, 250,000, 1 minus 10% to the exponent of 5. I'm getting 147,622,50. That's the book value. Then calculate the cost of the similar printer when the 5-year period expires. Now, the same printer which is new is expected to appreciate because of the inflation. Inflation is growth. Okay, so we're just going to have A is equal to P into 1 plus I to the exponent of n. So 25,000 into 1 plus 8% to the exponent of 5. Let me try to squeeze it in. Okay, so 25 is saying plus 8%. That gives us 36,732,02. Okay, that is the new price of the machine in 5 years' time. Then 5.1.3, the school is going to sell the used printer for just 95% of its book value. Calculate the amount of money that must be saved in order to have enough to buy the printer. So what is the book value? Is this much. So we need to get 95%. So I'll say 95 over 100 multiplied by the 147,622,50. So 0.95 times 147,622,50. That gives me 140,241,38. So this is what the school is going to get out of that old printer. Now, to get the amount that must be saved, we must get the 332,02. We subtract the 140,241,38 so that we can see. So we're subtracting 332,02. So we're ending up with 227,090,65. So this is how much the school must save. All right. All right. Okay, then 5.2, a company has invested and has an investment account with Bank A, which offers this effective rate competitor bank B offers interest rate of this compounded monthly. Which bank offers the base rate? Now, for us to get the bank that offers the base rate, we need to just have a common kind of ground for the comparison to take place. And in that case, we can change this interest rate of bank B to effective. Remember, the formula we said would be 1 plus I effective is equal to 1 plus I nominal over m to the exponent of m. Okay, so since this is 11,5, I'll just do it this side and say 1 plus, we said I effective, 1 plus I nominal to the exponent of m. So my I effective is going to be 1 plus 11.5%. How are we compounding this? We're compounding it monthly. So I'm going to divide this by 12 to the exponent of 12. This one must be transposed to that side. When I try to put this into my calculator, 1 plus 11.5% over 12 to the exponent of 12. This is going to give me 1,1 that. Then I think the answer, I'll have to multiply it by 100%. I go. Is of is of. Wait a minute. We said 11.5% compounded monthly. Let me just do it again. Said 1 plus 11.5% over 12 to the exponent of 12. We're subtracting a 1. Yes, I had added. Then I multiply by 100. I'm going to get 12.13%. Now they're asking which bank offers. This is 12.13. This bank A is offering just a 12. So in this case, we're going to say bank B is offering the best. All right, then the company will invest the following, or it will invest using bank B. Okay, invest money into a lump sum account that will get to 280,000 in 5 years. And then after 2 years, the company experiences difficulty and withdraws the 50,000 from the account. Determine the minimum amount of money that you have to invest so that you end up with this. Now, what we need to know is that since there is a difference in the amounts, we definitely need the timing. Okay. So if this is our T0, initially, there was a lump sum that was invested. But then the total number of years will be 5. And we need 280,000 within the account. Okay. They are telling us that after 2 years, let's say this is T2, there was a withdrawal of 50,000. So which means that the P amount, I'm going to take it to be growing for 5 years. And then this 50 is just going to grow for, I'll use 3 years. Okay, so I'll say that my P into 1 plus my I, let me use the 11.5 compounded monthly. So that's 11.5% over 12 to the exponent of 5 times 12. I'm subtracting the 50,000 into 1 plus 11.5% over 12. That's going to be 3 times 12. This must give me the 280,000 altogether. Okay, because remember, this 50,000 is going to be there for like 3 years. If I'm subtracted with the interest that it would have accumulated in. So when I simplify this first part, what's 1 plus 11,5 over 12? We say percent, man. Say percent. It's giving me some big numbers, but let me use the fraction. That's 2423 over 2,400 to the exponent of 60. I'll just move this whole thing to the right-hand side, which is going to be addition. Okay, 280. Yes, it's 280 plus, I'm going to say 50,000. No, that's 500, that's 50,000. Okay, that's 1 plus 11,5% over 12. Okay, to the exponent of 36. I'm going to make it that. So I'm ending up with 350,483,6217. Then I'll divide both sides by this bracket that is next to 2. Over 2423 over 2.4 to the exponent of 60. Divide by 2423 over 2.4 to the exponent of 6. That cancels that. And then what do we end up with? 2423 over 2.4 to the exponent of 60. That is giving me it's giving me 197,759.59. So this is how much was invested, 197,759 on that. All right, guys, so that is question number 5, the finance part. Question number 6, if there are any variations, please, we shall acknowledge your positive feedback and positive feedback. If f of x is given as this, so which type of function is this? Now the denominator is x. So this is a hyperbole. Okay. Calculate the value of k if k and 2 is a point on f. So k represents the x and 2 represents the y. So in other words, where we see f of x, that is our y. We're going to replace the y with a 2. So that's going to be something like 2 is equal to 3 over k plus 2 minus 1. Move this one first. It's going to be a 3 equals to 3 over k plus 2. Then cross multiply. So that's going to be a 3k plus 6 is equal to 3. Move the 6 now. 3k is negative 3, which means k is a negative 1. Then write down the horizontal and vertical asymptotes. Remember what we said? This is the vertical. Just switch the sign. X is negative 2. And then this one here with this sign represents the horizontal. We're going to say y is equal to negative 1. Okay. Then 6.3, calculate the coordinates of the y-intercept. So y-intercept, we say x is a 0. It's 1 mark. Just put this in a calculator. So it's going to be something of the nature 3 over 0 plus 2, which is a 2 minus a 1. So what is 3 over 2 minus 1? That must give us 3 over 2. No, it's a half, which is 0.5. Then calculate the coordinates of the x-intercept. Where there is y, replace with a 0. Okay, so you're going to move the one that side. So you have something like 1 is equal to 3 over x plus 2. Cross multiply, x plus 2 gives you a 3, which means x is a 1. Then what do they want you to do? Sketch. So even if they do not break this down, 6.2, 6.2, 6.4, and then they just give you this question sketch, and probably give you 6 marks or 7 marks. These are the steps to follow. Identify the asymptotes, the x-coordinates, or the x-intercept and the y-intercept before the sketching. Now, one thing we also need to know is that our A is a positive 3, which means we expect the graph to be in quadrant 1 and quadrant number 3. So let's start by just drawing our Cartesian, just a simple Cartesian. Okay. Remember, you don't have to be very, very accurate. It's a sketch. So we said x was a -2 and y was a -1. So if I make this x -2 and then y is a -1 somewhere here, just dotted lines. Asymptotes, we're done. Then the intercepts, we say x is a half, no, y-intercept is a half, positive a half, positive a half. So if this is a 1, then a half should be there. Okay. And then this x is a 1, y is a 0. So 1 can be just somewhere there, doesn't matter. So just sketch a graph that passes through those points and moves towards your asymptotes. It should just look as just like a hyperbola. And then this other one doesn't have any coordinates. So just complete it in that sort of point towards the asymptote. So that is the hyperbola that we wanted. So when you're marking, you just look at the intercepts, you look at the asymptotes, and then the shape. Does it look like a hyperbola really? Yes, you get your marks. Then one of the axes of symmetry, oops, I forgot to tell you about it, but we can discuss it. Axis of symmetry has a negative gradient determined this equation. So with axis of symmetry, especially with a hyperbola, we can have one that is moving in this direction, passing through the intersection of the asymptotes, and then we have one that is moving in this sort of direction. Okay. Now, the general equation is just a straight line, but this one is a special straight line because the gradient is always 1. So it's either x plus c or it's negative x plus c. So they want the one with the negative gradient. So you're going to focus on this. Now, how do we get c? The coordinates of the asymptotes. Coordinates of the asymptotes. So the asymptotes are meeting at -2 and -1. Where there is y, put a -1. Where there is x, put a -2. And then we look for c. So c is going to be a -3, which means the equation is -x minus 3. This line here that is moving in this direction. It's cutting the y-axis at -3. All right, good people. So it said y is equal to -x minus 3. Then 6.7, determine the value or values of x, for which this, remember this is our f, is greater than this. That's what we got here, which is our axis of symmetry. So we say for as long as the graph is, or for as long as the question is talking about inequalities, so where do we find the hyperbola to be above this line? So I'll go back to my graph and see that the only arm of the hyperbola that is above this line, the negative value, is just this arm. And what are the x values? From -2 to the positive infinity. So all I'm going to say, I'll say x. Okay. X has to be greater than -2. That's why it's a 1-mark question. Then the graph of f is transformed by a reflection over the x-axis, followed by a translation of 4 units in the positive x direction. Now, what this means is that whenever we reflect about the x-axis, the whole graph is affected. In other words, we introduce negative signs. So the reflection is going to be like negative f of x, which is the same as negative 3 over x plus 2 minus 1. When you open that up, it's a negative 3 over x plus 2 plus a 1. This is the reflection. Then when you talk about the translation of 4 units to the positive, then we switch the sign. Okay, we assume that we are talking about the positive rate. So where there is x, we're going to subtract a 4 plus 1. Simplify this. So negative 3 over x minus 2 plus 1. So this is the new equation that we are getting. Because the translation is points in the positive. Had it been that there was a translation up or down, then the one was going to be affected. So guys, that is question number 6. 7, parabola and the straight line. So they gave us the general equation of the parabola in just a straight line. As sketched below, we have these points, x-intercepts of f. Point M is the y-intercept, and N is the turning point, axis of symmetry. Oh Lord, it's a whole lot of information. Then they want us to get the value of Q. Q is the y-intercept of the straight line, but it is also the y-intercept of the parabola. So from the equation of the parabola, this last number, or the constant, represents the y-intercept. I mean, along the y-axis, x is a 0. When you substitute x with a 0, you'll be left with a 5. So we're going to say that Q is a 5. Then 7.2. Let me just jot it up today so that I can have some space. So we say Q is going to be a 5. Then 7.2, calculate the length of EP. Where's EP? E is there, and then P is there. So the question is indirectly asking us to determine the coordinates of P and L. So we know that it's along the x-axis. We need to find the x-intercept. It's along the x-axis, which means y is a 0. So I'm going to say negative x squared minus 4x plus 5 is a 0. Divided by negative x squared plus 4x minus 5 is a 0. I'll open my 2 brackets, x and x, 5 and 1, and this last term. I'll say plus and a minus, which means x is a negative 5, or x is the 1. What this means is that this is the 1. The negative 5 is by p. Okay. Now, when I'm getting the distance along the straight line, that is not at an angle. So it's either horizontal or vertical. Just get the big number 1 minus 5, which means we have 6 units. You can use your distance formula, you still get the same answer, but that is the greatest. Then they want the coordinates of n. So we know that n is the turning point. Okay. For me to get the x value, I can get the midpoint of negative 5 and 1, or I can use the negative b over 2a. Okay, so if I use the midpoint, it's going to be negative 5 plus 1 over 2, which is negative 2. Okay, and then with this negative 2, I just have to substitute it into the original. So negative and negative 2 squared minus 4 times negative 2 plus a 5. Use my calculator. That's going to be a negative 4 plus 8, and then plus 5. That's giving me 9. So N is going to be negative 2 and 9. Then determine the equation of the straight line H that is perpendicular to G and passing through N. So there is a line that is passing through N, but that line makes 90 degrees with G. So one thing we need to know about lines that are perpendicular is that they are gradients. or the product of the gradients must be -1. So M1 multiplied by M2 must give us -1. But we even know the gradient of G? We don't, but we can find it. Since this is a 5 and this is a -5, which means the gradient is just +1. The change in Y over change in X. Okay. So I'll say gradient of G is a +1, which means the gradient of the perpendicular is going to be -1. Since 1 times M2 should give me -1, that gives me -1. Then since it's passing through N, that is -2 and 9, I'll say Y minus 9 is equal to -1 into X minus -2. Open this up. This is going to be -X minus 2. Y is equal to -X minus 2 plus 9, which is -X plus 7. So that is the equation of that perpendicular line. Then calculate the average gradient between M and N. Where is M? M is 0 and 5. And then N is 2 and 9. So when they ask for average gradient, just the same gradient formula. Change in Y over the change in X. So it's more like Y2 minus Y1 over X2 minus X1. So I can say 9 minus 5 over 2 minus 0. So 9 minus 5, that's going to give me a 2. Does that make sense? It's a 4. Divide by 2, then I'll end up with a 2. Then calculate the length of NT. Remember, NT is the distance between the two graphs. So when this happens, there's something common about this point, or about these 2 points, is that they have the same x-coordinate, which is a -2. You can start by getting the coordinates of T. So the coordinates of T, but we already have the coordinates of N. Now, since the equation of G, now since we have the gradient of 1 for G, and we also have the y-intercept of 5, so we know that G is going to be Y is equal to just X plus a 5. Then if X is -2, then Y is -2 plus a 5, which gives me a 3. So which means the T is -2 and 3. But our N is -2 and 9. Then just subtract these 2 values, the Y values, because the X values are the same. So I'm going to say MT will be 9 minus 3, which is basically 6 units. Then determine the coordinates of S. What did they say about S? Told us that A's and A must symmetrical with the axis of symmetry. So the distance across it, okay, from here to here is the same as from there up to there. Now, for as long as symmetrical, I mean they will share the same Y value. So we know that S is going to have 5 as the Y. And then how about the X? Let's see. If from 0, the axis of symmetry is -2, these are 2 units. So we also need to count 2 units. So which means S is going to be -3. That's how I would have gone about that, but I don't know why it's 3 minutes. Sometimes the people can be generous. Okay, 7.8 for which values of X will F of X minus 2 of X equal to 0. So this is the same as them asking me F of X, being the same as F of X. Where do we find the 2 graphs to be equal? You say 2 graphs can only be equal at the points of intersection. They're asking for which values of X. So at point E, X is a -5. At point A, X is a 0. So you're going to tell us that X is either a 0 or X is a -5. And then where do we find F of X times G of X to be less than 0? Now, in this case, we need to look for the regions where one graph is below and another graph is above, because we're talking about the negativeness. So let's see. If I look at this kind of scenario at point E, and then let's see at this point E. Okay. At E and below, the graph is okay, so at point E, we can see that both graphs are below the y-axis. So it's a negative and negative. In this section, there will be a positive. Okay. Then between E and P, both graphs are still above. So this is a positive, that's a positive. So this region is also a positive. Let's see this point P. At P, okay, F is down, G is above. So one is a negative and then one is a positive. So a positive and negative, overall we have a negative. So this is the region of interest where it's less than 0. So X, what are the coordinates of P? We said it's a 1 and a 0. So for which values of X, we're just going to say X must be greater than 1. So that is question number 7. Number 8, the exponential one. Consider this function. Calculate the coordinates of the y-intercept. So y-intercept, you said X must be 0. So that's going to be 3 times 2 to the 0 minus 6. Anything to the exponent of 0 is a 1. So our answer here is a negative 3. Then calculate the coordinates of the x-intercept. Y is a 0, so 0 is equal to 3 times 2 to the x minus 6. Move the 6 that side, divide by 3, we're going to be left with a 2 is equal to the x, which means x is a 1. Then they want you to sketch. I don't know, let me just sketch it somewhere here. Please, bright color, not quite. Not really quite. Something out of visual. Let me have that. So we know that negative 6 is our asymptote. I'll just put it somewhere there. Let's say this is our negative 6. Then this negative 3 is the y. The negative 3 is somewhere there. Then positive 1 can be somewhere there. We can say that our A is 2. It's greater than 1. So it means this graph is increasing. And then we have something like that. Okay. Then they want us to write down the range. Range, we said y values. We use the asymptote. So y is greater than negative 6. Guys, that is question number 8. 9, probability. Says post direct at a school, analyze data to determine how many learners play sports and what gender. Okay. Data is given in the table. So the totals have been given to us. In cases where the totals are not there, you have to calculate the totals. Okay. Then the probability that a learner selected is a male. So probability of male. How many male learners do we have? 120. So it's 120 divided by 236. When you try to simplify this, 236, I'm getting 30 over 59. You can leave it like that, or you can give it as a decimal, no problem, which is 0.51. Then female and play sport. Where is female? But play sport is a 67. So female and plays, we're saying 67 over 236. So 67 divided by 236, we're getting the same answer, I suppose. Yes, if you want to give it as a decimal, it will be 0.28. This is 0.5251. 51. Okay, so 9.2, are the events being male and does not play sport mutually exclusive? So mutually exclusive simply means events that cannot happen at the same time. Okay. But the question is asking is it possible for someone to be male and not play sport? We have people that are male and they're not playing sport. So it's possible. So in this case, we have something that sort. So these events are not mutually exclusive. Are the events mutually? The answer is a no. Why? Because male and does not play is not equal to 0. Then lastly, are the events male and does not play independent? So number one, we have male and does not play. Okay, it's going to be the same as the probability of male and then the probability of does not play. So probability of male and does not play, how many males do not play? It's 51. So I'm going to say 51 over 236. I'll just write the equal signs for now. The probability of male, we got 30 over 59. And then probability of does not play. So how many people do not play sport? It's 100, regardless of whether they are male or female. So it's going to be 100 over 236. When I simplify my left-hand side, remember I will say 51 divided by 236. That gives me something, which is 0.2161. We said in this case, we can round off to 2 decimals, which is 0.22. Let me do the calculations on my right-hand side. So 30 over 59 times 100 over 236. So this is giving me 0.2155. So which is approximately 0.22. So final answer rounded off to decimals gives us the same. So therefore, the events are independent. So therefore, the same events are independent. So that's how 9.3 would have been worked out. Then question 10, the 3 sets. Survey regarding the most read magazines was conducted among 84 high school girls. 3 magazines, namely the Grammar, Dram, and the Teen, were used. All that information is there. Then they want us to get the value of C. Okay, so what we can see is that we have a total of 84 lines. But the question is telling us that, or the statement 75 read at least one. What this means is that 75 people need a reading. Whether they are reading 1 or 2 or 3, 75 of them. So C represents people that don't read at all. So for us to get C, just get 84 minus 75. Okay, so 84 minus 75, I'm getting a 9. So which means 9 people do not take part in any sort of reading. Probably they love watching stuff. Then express F in terms of X. This is F. How many read the Teen? So Teen is 41. Okay, so this set is equal to a 41. So for us to get F, we must get 41. We subtract everything within this circle. So I'll say 41 is equal to F plus X plus 8 plus 10. So that is 18. Okay. So 41 minus 18, I'm getting the 23. Okay, so that's a 23 is equal to F plus X. Then make F the subject. So it's a 23 minus X. So that's my F. and then determine the value of x if E is given as that. So we said E is 17 minus x. Then we just have to add everything up and put it to 81. And let's see what we end up with. So it's going to be 13 minus x plus the 17 minus x plus the 13 plus the 10, the 8, the 9, and then another 9 must give us 81. Then what do I see? What do I see? I have 13 plus 17, that's a 13, that's a 40, it's a 53, a 61, a 70, having a 79. Now, my calculations, they are misleading me. There's also an X somewhere. Because we said 10, 8, 9. There has to be this X part, that X part, and then this X part. Let me use the calculator, guys. So 13 plus 17 plus another 13. No, it's not a 13, it's a 23. Yes, it's a 23. So it's saying 23 plus 17 plus 13 plus 10 plus 8 plus 9 plus 9. It's 89. Okay? This x and that x is minus 2x plus 1x, which is minus x, is equal to 84. You know the 89, that's negative x is negative 5, which means x is a 5. So guys, that's that with paper 1, and all the best. Let's meet in the paper 2 prediction.